Okay, let's start. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to A-Level Maths with Mr. Ali live lesson today, second of the live lesson series where we're going through A-Level Maths Year 1. Today's topic is problem solving, and I've got a nice little game to show you if it has. Nothing seems to have loaded quite yet, but the idea of the game you can get from this picture here, where you've got the red car in the middle and it's stuck between lorries and other cars, and in order to get it out of the car park you have to get it from this position here out into the exit here. Anything that is in the way or anything even that's on the screen can be moved only in the direction that it's facing or in reverse. So it can either go forwards or it can go backwards, but it can't. Maybe that's the game. Let's just try that. Okay, that's probably a bit of an easy one. I think we'll skip that one. Coming back to this game, which is a bit more up to the level that I need you to be at. We've got the red car here and it needs to move out. So have a think, which cars and which lorries would you move and how, in order to create space so this red car can move out. I'll give you 1 minute to think about that. And just a few more seconds. Okay, and any answers feel free to put into the chat window. Let me just check that chat window is working. Okay, fantastic. So the idea here is that if you look at what's directly in front of the red car, that's probably not going to help much. What you've got to do is work kind of outwards in and think, okay, nearest the exit is this yellow truck. How can I move that? Well, I've got to get this blue car out of the way, and then I can move the yellow truck down. Is that going to be enough? Not quite, because when it comes to the blue truck, you're going to have to move that downwards, not upwards, because if you moved it upwards, it'd still be in the way. So let me just see if I can just show you a little bit. The website's not quite working as it should, so let me just show you by taking a little screenshot. So this blue truck, if you were to move it up, it'd still be blocking the red car. So the only way to really get that out of the way is to move it down. But you can't move it down until you've got some space here. So then you think, okay, well, how can I move this green truck? Moving it one across wouldn't really help much. It still would be in the way of the blue truck. So the blue truck wouldn't be able to move all the way down because it still hit the green truck. So then you think, okay, well, how can I make space for the green truck to go all the way out? And this kind of thinking of starting from the end and then thinking, before that, what do I need to move? Before that, what do I need to move? Before that, what do I need to move? That's a kind of mathematical thinking that will really help you in your A-level maths, believe it or not. But ultimately we should get to a position where we can start to figure out how to move this red car out of the car park. And I believe it goes something like this. Now that should create enough room to go all the way down for the blue truck. Probably want to move the blue car first so that at least the blue truck and the yellow truck now have space to move. That's the blue truck out of the way, and that's the yellow truck out of the way, and that's your red car all the way through. Okay, so that technique, working backwards from where you need to get to, that's a really powerful technique that if you can master that technique, if you can get your brain thinking in that kind of way, then your ability to solve really tough maths questions will be really, really good. If you're not there yet at that level, that's okay. There's other techniques, and I want to show you that today. So we're working through the book that I showed you yesterday, and we're looking at problem solving. So let's take a look. At today's problem. And really, it's not the maths that I want you to learn. You should know the maths, the techniques from GCSE. It's the thinking. It's how do you go about using your thinking skills. How can you develop your thinking skills? How can you improve your thinking skills? And take the GCSE maths that you know, even the A-level maths in a few months' time, and apply it to questions where it's not so straightforward. Like the red car, getting the red car out of the car park. It's not as straightforward as, okay, answer this, this and this. But let's make it as straightforward as possible. So let me give you about 30 seconds to read through the question. Okay, that's hopefully enough time to realize that we are getting a piece of cardboard. The cardboard is a rectangular sheet, and from that rectangular sheet of cardboard we're cutting out a semicircle, and we're throwing the rest away, just leaving the semicircle. And with the area of the semicircle, the area of what he throws away is given to us, and what we want to know is how long is the straight side of the semicircle. So that's the question. The technique I want you to focus on today is called talking back to the question. Talking back to the question. And I'll show you what I mean, because it's probably a new technique that you haven't come across before, but maybe you've used it without realizing. But the idea is that as you read each part of the question, you really want to think, what can I say back to the question? What can I talk back with to show that I know something as well, that I can contribute, I can put something on the table in terms of numbers, in terms of anything that you know mathematically about what useful information there might be. Let's just go from the beginning. And while I'm reading, I'm going to pause at a certain place, and you have to think, what can I say back to the question? Let me give you maybe an easier example just to start off with. If I showed you a question something like, Adam has 30 marbles, he gives 20% to a friend, he shares half of the remainder with his brother. How many marbles does he have left? By talking back, what I mean here is that at each stage of this question, in your mind, your mind would be buzzing away thinking, hold on, I can say something here. So Adam has 30 marbles, fine, there's nothing that you can really talk back there. He gives 20% to a friend. Straight away your mind should be buzzing and saying, hold on, 20% of 30 marbles, that's 6. So I know, and I can talk back to the question and say 6 have been given to his friend. And that would also lead you on to something else, but let's just keep it simple at the moment. Then you read the next bit, and he says he shares half of the remainder. As soon as you see half of the remainder, again you're thinking, well, hold on, the remainder, he had 30 and he gave 6, so you're thinking 24 would be the remainder. This is called talking back. The question didn't ask you how many did he give to his friend. The question didn't say work out the remainder, but this is you reading the question, and as soon as you realize that there's a point where you can give something back to the question, you're talking back. You're saying, was the 20% to the friend? That means 6 he gave to the friend. The remainder, that means there were 24 as the remainder. Half of that, you're thinking, well, half of the remainder would be 12. And then that's what he gives to his brother. And then how many left? Well, then you've got the answer. But it's not the answer that I'm trying to help you focus on today. It's what did we talk back with, and at what point, and what can we do to apply that to any general problem solving question. So let's try that again. And have another read of the question while I do a quick diagram. The diagram is not the important thing today, but it's normally a good thing to do when you're working with questions that can be visualized. Have a read of the question and think, at what point can you talk back? And what would you talk back with? Just a few more seconds and then I'll show you what I mean. Okay, fantastic. So just to help you visualize this, there's a rectangular sheet of cardboard and he's making a semicircle and he's throwing it away. So let's see, what can we talk back with? So it's just starting at the beginning, and just relax and just let your mind work on anything in the background that you think you can talk back with. Armand cuts out a semicircle of cardboard. Okay, straight away when you're reading semicircle, and you've read the question once already and you know it's about area, then straight away when you see semicircle, your mind should be thinking and talking back with the formula for the area of a semicircle. If not a semicircle, then at least a circle. You're thinking, well, the area of a circle is pi r squared, and then the area of a semicircle would be half of that. So you're just talking back, putting that on the table, putting that on the sheet, putting that on the paper as, yeah, I know something about the question too. Cuts out a semicircle, and then you go on. Of cardboard from a rectangular sheet. I'm going to skip rectangular, that's very, very obvious. Rectangular sheet of cardboard measuring 20 by 40 centimeters. At this point, your mind has to be talking back, and you're thinking, well, straight away, I know the area. If there's a rectangular sheet of 20 by 40, I know that that's going to give me an area of 800 centimeters squared and throws the rest away. At this point we could do something as well, but I'm just going to carry on. The cardboard he throws away has an area of 398.08 centimeters squared. So here you could look at your picture, and what you're saying is that the area on the outside of the semicircle is 398.08. Because you talked back earlier on, you know that the area of the whole rectangle is 800, and now you should be talking back again and saying, well, I now know that the area of this semicircle would be the 800 take away the 398.08. So you're thinking 800 take away 39.808, that would give me the area of the semicircle. That's what's in your mind. So let's do that. And that 401.92, we can label that as the area of the semicircle. Just need to make that a little bit smaller. And now we can forget about the rest of the question. It doesn't really matter about how big the rectangle was, how much he threw away. All we're concerned with is that the semicircle has an area of 401.92. And then you go on from there and you think, okay, just crossing out the working out just to make it easier to see. Carry on reading. How long is the straight side of the semicircle? So there's your semicircle. We know the area of the semicircle is pi r squared divided by 2 as a formula. We want to work out the straight side. So you probably want to just say here the straight side, that's the diameter. Just to remember the diameter and the radius. If you can find one, then the other one's very easy because the radius is half the diameter or the diameter is double of the radius. So just keep that in mind. But at this point we can simply say the area of the semicircle, pi r squared divided by 2. That's the area of the semicircle as an expression. As a number, it's 401.92. If we put those two side by side, we can say that's the equation that I'm trying to work out. The pi r squared divided by 2 has to give me 401.92. And if your algebra is fluent from last year, you should know what to do there. I'll just give you a few seconds to work that out. A few more seconds and then I'll take answers. Okay, that's hopefully enough time to work out what the radius would be, what r would be. Let me just check the chat window, just check if there's anyone that's able to give an answer on that. If not, don't worry, I can go through it, but very, very impressed if you can give me an answer that you might have got. So here, first step would be to try and get rid of this divide by 2. So we'll times by 2. There's different ways of solving, but really should be at a level where you can take things from one side of an equation to another side. Divide by 2 can become a times by 2 on the other side. So if I take the divide by 2, actually I'll just do it so you can see the movement. I'm taking the divide by 2. The 2, which is a divide by 2, is going to the other side. Because it's a divide by 2 here, it becomes the opposite on the other side, which is a times by 2. So I can say that there's a times by the 2's gone over, and that's become a times. The divide by 2 has gone away from the left now. Just straighten that up a bit. Then I want to get r on its own. There's a pi being timesed at the front, and there's a square as well. You always try to work backwards. You always try to work what's the opposite of BODMAS, really. So because squaring gets done first in BODMAS, we're going to do that last when we're trying to unravel it and get to r. So pi is the obvious one to move out. Same technique. If I move it to the other side, at the moment it's a times by pi, which will become a divide by pi. And then if I want to get rid of the squaring, then that's square rooting both sides, or just move it to the other side and it becomes a square root. And that has moved now. So that's your expression for r. If you work that out, you should get a number close to 16. If anyone's done that, then please type it into the chat window and I can check your answer. Okay, and I can just tell you what that will be. Always try to write your full answer before you start rounding anything. My GCSE maths teacher used to tell me that, look, sometimes you're going to need that answer for the next step, for later steps in the question. So don't start rounding too early, otherwise your next step is going to be inaccurate. And his name was Mr. Pennell, just in case he's watching. Diameter here is what we're looking for. At the moment, this is the radius. So just one simple step, we're going to double it, and that will give us the diameter, the straight side of the semicircle, and that becomes 31.99. That is the last step, and you're free to round after that, but always try to just put the full answer there in case you make a mistake in the rounding. Not because you don't know how to round, but sometimes in the exam, and I've done quite a lot of exam marking as an examiner, you can lose a mark just because you thought it was appropriate to round to, say, 2 decimal places, whereas the mark scheme said 3 significant figures. And that's just a difference in rounding, and it would be silly to lose more than 1 mark on that. If you've put at least the full answer, then at least the maximum you're going to lose is 1 mark. But if you can get the rounding to normally 3 significant figures is the standard of what's expected. So 32.0 to 3 significant figures would be the side of the semicircle. Okay, just a quick recap on the method really. It's not the question you're trying to learn here. The chances of you getting a question in the exam where you're asked to work out the area of a semicircle is very unlikely, but what you're trying to do is understand about the talking back. So here, what you what you should have noticed is that at each point in the question I'm talking back. Armin cuts out a semicircle. I'm talking back and saying I know the area of the semicircle is using the formula pi r squared divided by 2 of cardboard from a rectangular sheet of cardboard measuring 20 centimeters by 40 centimeters. You stop and you think, I can talk back here. I know that the area of a 20 by 40 centimeter sheet would be 800 centimeters squared. Don't worry so much about the units. And throws the rest away. At this point you could talk back in terms of a formula, but if you just carry on reading it becomes a lot easier. The cardboard he throws away has an area of 398.08. So now you know the 800 to begin with. Take away the 398.08, and that will give you the area of the semicircle. Then you focus on that and you think, well, if that's the area as a number, the area as a formula was pi r squared divided by 2. Put those two as equal in terms of forming an equation, and then solve it using any GCSE methods you know. In this way I was taking things to the other side. How long is the straight side of the semicircle? Here you've got the radius, which is half the diameter, so we just need to double that and we get 32.0.